All right, so every successful app eventually hits a wall. And funnily enough, that wall is its own popularity. Today, we're going to dig into a really critical step in scaling, database replication. We'll break down how you go from a single server that's just getting hammered to a super high-performance system. And we're pulling these ideas straight from scaling a system from 0 to millions of users.
I mean, it's the best problem you can have, right? Your app is blowing up, the user base is growing, traffic is just surging. But then, things start to get slow. That success you worked so hard for, it's just created your first huge scaling headache.
Okay, so let's just assume for a second you've already taken that first big step. You separated your web server from your database server. That's a massive win, right? It lets you scale them independently. But what happens when that single dedicated database starts to, creak under all that pressure?
And this is what happens. Your app is a total hit, but your users are starting to notice. Pages load slower, things just feel sluggish. And the culprit? It's not your web server this time. Nope, it's the database. It has become the single point of failure, the bottleneck. But the real question is, why?
See, the problem isn't just traffic in general. That's too vague. It's a very, very specific type of traffic that's causing this whole mess. And to really get it, we need to look at what people are actually doing when they use your app. This chart right here, it just nails the issue perfectly. Think about it. For most apps, what do users do? They're reading stuff, they're viewing profiles, scrolling through feeds, looking at products. That happens way, way more often than them writing data, like creating a new post. This imbalance between reads and writes, it can be absolutely massive. And that right there is the root of our problem. So here's what's really going on. That one lonely database server is trying to do everything. It's trying to serve every single one of those read requests while also managing all the writes. The sheer number of reads just completely overwhelms it. And when it gets overwhelmed, the whole system slows down for everybody.
Okay, so how do we fix this? How can we possibly serve all those read requests without just crushing our one database? Well, the solution is actually pretty elegant, and the absolute best way to wrap your head around it is with a simple analogy.
I want you to imagine a library. And in this library, there's only one original master copy of a super popular book. To read it, everybody has to get in this super long line and wait their turn. It's a nightmare. But now, what if the library made, say, dozens of perfect read-only photocopies? Suddenly, anyone could just grab a copy and start reading at the same time. No waiting. Well, that is the core idea behind database replication.
So let's map this out. It's a one-to-one comparison. That master book, that's our primary database. It's the one single source of truth where every change, every update has to happen. And those photocopies, well, those are what we call replica databases. They are the perfect read-only copies that are there just to handle all of those user read requests.
All right, so let's see how this simple idea builds into a really powerful architecture. Using this primary replica model, we can now intelligently split the workload and completely, totally eliminate that read bottleneck we were talking about. So this is what we call the primary replica model. Now, you might also hear it called by its older name, the master-slave model. Same thing. The most important part here is that we're creating specialized roles. We have one database, the primary, that is in charge of all the changes. And then you have a whole team of replica databases whose only job is to handle that massive flood of read requests. Okay, listen up, because if you only remember one thing from this whole explainer, make it this. The primary database is for writes. The replica databases are for reads. That's it. Any command that changes data, think insert, update, delete, it has to go to the primary. And all the commands that just fetch data, your select queries, those get spread out across all the replicas. That is the fundamental rule. Don't forget it. So you might be wondering, how does the application know where to send everything? Well, it's actually pretty simple logic. You just ask, is the user changing data? If yes, .request, the insert, update, or delete, goes straight to the primary database. Only there. Are they just looking at stuff, just viewing data? Then that read request gets sent to one of the many replica databases. Usually you'd have something like a load balancer in front of them to spread the work out nice and evenly. Okay, so now that we know how it works, what's the payoff? What do we actually gain from all this? See, this isn't just about fixing one little problem. This architecture unlocks two huge benefits for your entire system. We're talking performance and high availability. Benefit number one, performance. That read bottleneck we had before, gone. Poof.
Instead of one server just struggling to keep up, now we can have a whole fleet of replica servers, and each one is only handling a small piece of that read load. This lets us process a massive number of queries all at the same time, in parallel. And that makes the whole application feel fast and snappy again. And the second benefit, and honestly, this is a huge one, is high availability. Think about it. What happens if your primary database just dies? In the old setup, your whole site goes down. Game over. But now, we can just promote one of the replicas to become the new primary. Since it's already got an almost current copy of the data, this failover process can happen really quickly, keeping your application online and slashing your downtime. So there you have it. Database replication is this incredibly powerful tool that just crushes the read-heavy workload problem and makes your whole system more reliable. It's a really fundamental pattern in system design. But as you probably know, scaling is a journey, not a destination. And solving one bottleneck has a funny way of revealing the next one. All right, let's just quickly lock in the key takeaways here. Are you getting swamped by read traffic? The answer is replication. Remember the rule. Primary database handles all the writes, replica databases handle all the reads. And what do? You get a huge boost in both performance and availability. It's just a core pattern you have to know for building reliable apps that can actually scale. And that leaves us with one last, kind of scary question. We've solved the problem of having too many requests, right? But what happens when we just have too much data? What do you do when your database gets so big it literally can't fit on a single primary server anymore? Well, that, my friends, is the next big challenge in our scaling journey.